Okay, there's a question from students based on the graph of GDP per capita versus overall well-being. I would say there's a link between GDP per capita and overall well-being. Is that correct? Statistically, yes, it is correct. But then the point I made is not perfect correlated. It is correlated, but it's not perfect. So there are other factors matters to the well-being of the nation. Okay, so now just back to this example. So in this example, the market basket is given by here. Okay, so we construct a market basket that includes 200 orange, 50 grapefruits, and 100 lemons. And then there's this column give you the price at one point, and this column give you the price at other moment. And there's here we are trying to calculate the cost of this basket at a different time point so that we can value the aggregate price level. Okay. And then the way we do that is look at here. So calculate the cost, right? So essentially use 200 times the price, 50 times the price, and 100 times the price. Right? And then so we get 95. This is the cost of this market basket. Now, similarly, we can find out the cost of this same basket after frost. So now we use quantity. So it's coming from 200 times the price here, 50 times price here, 100 times price here. So that's going to give you 175, right? So this is how we calculate the cost of a market basket. But in reality, the market basket is way more complicated than here, right? So I show you the example before the break. Now, given the cost, we can find out the price index. So the cost we just calculate is a dollar term, right? So now, given the cost, we calculate the price index by this formula. Okay, cost of market basket in a given year divided by cost of market basket in base year. Okay, so this years you can change this to given moment or given time, and this base year you can say it's given base moment or base time. The same sense, right? Now, in the previous example, so let's just copy paste the price, right? So 95 versus 170. So 95 versus 170. Okay, and then so if we let's just call this pre and post. So if we use pre as the base year, and then the price index of post is going to be 175 divided by 95 times 100. All right, so this is how we calculate. So maybe we can use examples to understand. So there are 2 years, 2011, 2012. Suppose 2011 is base year. Okay, and the market basket includes 200 orange, 100 apple, 100 banana. So this is a market basket. Now, this question asks you, what is the value of price index in 2011? Okay. Before you do the calculation, let me remind you. So what is the price index? So price index is called PI, equal to cost in current year, which is 2011, right? Divided by cost in base year. But now this one is 2011 times 100. Hence, this question you don't really need to calculate. So the answer is going to be, because you're looking at the price index in base year. Now, same example. Okay, so let's just copy paste 200, 100, 100. So now this one asks what is the price index in 2012. Then, so what do we need to do? You need to find out the cost in 2012 divided by the cost in 2011. So now let's see how we do that. So 200 times now 2012, the price is 40 plus 100 times price of 40 plus 100 times price of 50. And then in 2011, 200 times 50 here plus 100 times here a quarter plus 100 times here 40 cents. Okay, and then we multiply by 100 for normalization. So the answer is D. Okay. Now, given price index, we can calculate inflation. But what is inflation? Inflation essentially is the percentage change in price index. Okay, so that's given by the formula at the bottom of this slide. Okay, so this formula just give you the way to calculate percentage change in price index. Okay, and then depending on which market basket we use, like here, so we use the market basket of a typical urban family. And then, so this is going to be consumer price index. And then later, so you're going to see we may calculate producer price index. And certainly we use the market basket of a typical American business, because here is family, so that just goes to consumer. If it's a producer, and then goes to business. All right. Now let's just look at this example to see how we calculate inflation rate. So this asks you to calculate inflation rate between 2011 and then 2012. Now maybe we can go back to the previous slides one more time. Okay, and so to look at how we calculate the inflation rate. So again, so this is a percentage change in price index. Now you may be wondering, okay, so you feel free just go back, maybe just let me just go back one more time. So how we calculate price index? Price index use the cost in a given year divided by cost in base year. Okay, so now, okay, so go to that questions. So let me write down all the information we need. Oh, apology. Okay, so all the information we need. First, we need the price index, which is the cost in current year divided by cost in base year. So this is price index, step number one. Step number two, so to calculate inflation is a price index in, like in here, so it's in 2012 divided by price index in 2011 and minus 1, right? Because this is percentage change. Okay, so we need to take 2 steps. So this 2 step is going to help you to find out the inflation. Now let's just do the calculation. Okay, price index. So you can use 2011 as base year. Okay, 2011 as base year. First, calculate the cost of the basket. Again, so this 200, 100, 100. Right, and the cost of this basket is in 2011 is going to be 200 times 50 plus 100 times 20 plus 100 times 40. Okay, so this is step number 1. So that's going to give you the cost in 2011. Now next, you calculate the cost in 2012. That's going to be 200 times 40 plus 100 times 40 plus 100 times 50. So it's going to give you cost in 2012. All right. So this is going to be 100, 125, 165. This is 165. This is a cost. And this is 80, 80, 120. Yeah, so 120, 50, 170. So this is the cost, right? And then so we calculate the price index. So certainly 2011, the price index equal to 165 divided by 165, 100. And then price index in 2012 is going to be 170 divided by 165. Okay, this is around 103. Now, given the price index, we can easily find out the inflation rate is 3%. Okay. Now we have seen this slide before. Okay. And this is how the consumer price index look like in the US economy. And this is a log. Okay. So the log has 2 benefits. Number 1, just scale down. Make the graph easier to plot. And then number 2, by taking a log. So if we look at the difference between 2 data points, so for example here versus here, the difference between 2 log value can give you the percentage change. So this is the 2 benefit of log. Okay. But nevertheless, look at this log CPI. You can see overall from 1930 to 2013, the US consumer price index increased. But certainly there are time period when price decline, like in Great Depression. Okay. Okay, besides consumer price index, we also look at producer price index. The difference is, so the market basket is consumed by producer. Okay, what is the difference? Say, for example, the producer, they cares more about raw material, say copper, oil, right? But for the consumer, they care less about copper. Okay, so that's how PPI and CPI, they are different. So besides PPI and CPI, economists also use GDP deflator. But then what is a GDP deflator? One way to look at it is, so essentially GDP deflator, the market basket is defined by all goods and service we produced. Okay, so in some sense, so GDP deflator has the most comprehensive market basket. So PPI, or maybe you can just draw a diagram. So if this all type of goods and service we produced, and then we pick everything and compile our price index, and then this is GDP deflator. Okay. So now, if we look at some goods consumed by households, and then this is CPI. Now, if we look at typical goods consumed by producers, then this is PPI. Right? So that's how they are related. And so this is how those numbers look like in real world. So these three, they track each other. But certainly the GDP deflator is the least volatile. Why? Because this GDP include both market basket for producer and a market basket for consumer. Right? So it's average out, so it fluctuates less. The PPI is more volatile because so the price change is going to affect firm's business, and the firm's business, particular investment, is very price sensitive. But for consumer, so most of the consumption are less price sensitive. So, for example, with the price increase, can you really cut your consumption of your food? Not really. But for business, if price change, they can decide to slow down their expansion, right? So that's why they behave slightly different. But overall, they track each other. Okay. Now we don't have time to watch these. And I guess that's all for this chapter, right? So just in case there's something missed, but I think I covered everything. So you can still watch the video I sent you earlier. Now we move to next chapter, which is economic growth. Okay. So in this chapter, we understand what we mean long-run economic growth. And then, so we are going to look at factors that are crucial for long-run economic growth. After that, so we are going to see whether the country can catch up with each other or not over a long time. And finally, we look at the sustainability of economic growth. Okay, so this is related to climate change. Okay. Now, first one, so growth. What is economic growth? Okay. So economic growth, first of all, has benefit and cost. So we always use China as an example because during the past 30 or 40 years, Chinese economy experienced rapid expansion. So they have significant growth experience. So that's why we use that as an example to study. Okay. But by looking at China's economic growth, certainly we can see there are costs associated with the benefit of economic growth. Like one particular cost is air pollution or environmental damage. Right. So now we can compare in economies across time and space. But see, so that is based on what we just learned in previous chapter. Because in the previous chapter, we know we can look at GDP. And this is a good time to reflect what we have learned. We started with GDP, and then we differentiate between nominal and real. And finally, we also mentioned we may want to look at real GDP per capita. Right? So the real GDP per capita has three things inside. First, this is a measure of goods and service, which is GDP. Secondly, so we factor in price change or price difference, which is real. And finally, we look at per capita term. So that just normalized by population. Okay, so this is a key statistics, but certainly this is not a perfect statistics to comparing economy with the other economy. So on the very top is the United States, which is a world leader, okay, since 1900. So you can see the US economy over time is growing, right? We do experience some disruption, like Great Depression, right? Okay, but overall, the long-term trend is the US economy is growing and growing at a very steady rate, which is around 2% for more than a century. Now, if we look at India, so the economy is significantly poor compared to the United States, right? But interestingly, so the gap is changing over time. So at some point, so the gap is widening. But recently, so the gap starts to narrowing. So this is also true if we look at China, or maybe more significant, right? So particularly, so the gap in real GDP per capita between United States and China has been narrowed since 1980. So 1980 is an important year for Chinese economy. So this is the year when the central government decide to open door, decide to reform their economy, decide to introduce market economy. And in the following 4 decades, so you can see their growth is quite significant. The gap is rapidly narrowing. Okay? So this figure highlight what the growth means. All right. Now we can look at a practice questions to understand why we look at real GDP per capita. Okay. Suppose real GDP for Micronesia, so this is a fictional economy, is 200 million. This is a total. Suppose population is 10,000. Now we move to 2011. Population increased to 105,000. GDP, this is a total GDP, total real GDP increased by 5. Then, so the question asks you, what happened to real GDP per capita? Okay. So the brute force way to do that is just use real GDP divided by population. And then so we'll find out, so in 2010, it's going to be 200 million divided by 100,000. And then in 2011, it's going to be, because increased by 5%, so that's going to be 210 million divided by 105,000. You will find out, so these two numbers is exactly the same. This is a brute force way. But there's another way to look at it is, so this question says population increased by 5%. Real GDP increased by 5%. These two is going to cancel each other. So the answer is C. Okay, so hopefully you can see the reason why we look at real GDP per capita. Because if you look at real GDP, it seems like it's growing by 5%. But if you look at per capita term, nothing changed. Okay. Now, this is another way to look at the importance of economic growth. We zoom into US economy. we look at 1900 versus 2010. Okay. And so if we use 1900 real GDP as a normalization, which is 100, now you can see 2010. So we produce almost 8 times, or the real GDP per capita is almost 8 times compared to 1900. One way to interpret this is in 2010, the standard of living of a typical American is almost 8 times compared to a typical American in 1900. Right. So this is the benefit of economic growth. Right. And here, so this graph will give you a global view in terms of economic growth. So you can see, so there are regions doing extremely well, but there are regions doing poorly. So like North America, that's where we located, and Europe, Australia, and part of Asia, so they are doing well. And then Africa still is underdeveloped. So you can see there are many countries still lives under absolute poverty. Right. Okay, so now in the next slides, I'm going to introduce you the rule of 70. So essentially, this is the power of compounding. Right. So this rule of 70 tells us the time to double your GDP. Okay. So time to double your GDP or whatever variable you are interested in is going to equal to 70 divided by the growth rate. Just an example. If the GDP grow by 3.5% per year, and then, so this is going to take 20 years to double your income. Now we can look at 2 practice questions to understand this rule of 70. Suppose real GDP per capita grow at 2%. How many years it take to approximately double? And then the answer is very straightforward. It's going to be C. The rule of 70, 70 divided by 2. Right. Now the other one. So there are 2 economies. One, India. Right? So currently 3,000. Growth rate of 5%. The other is Italy with a per capita GDP of 24,000. The question asks you, how many years will it take for India to reach Italy's current level? Or in other words, with 5% growth rate, it takes how many years for India move from 3,000 to 24,000? Okay, first, so we need to find out what is the percentage change from 3,000 to 24. The answer is 8. Right, so you grow by 8 times. Now, the rule of 70 says, okay, 70 divided by 5, so that's equal to 14. 14 years to double. But in order to 8 times your GDP per capita, you need double 3 times, right? But in order to double once, take 14 years, and then double 3 times, it's going to take 14 times 3. So the answer is 42. Right. Now this slide just show you the growth difference across countries. On the far left, we have seen this successful story, which grew by almost 8% for more than 3 decades. Okay. On the far right, you have Zimbabwe. So they have negative growth rate. So United States has a very stable growth rate. And from here, use the rule of 70, so we can find out what the magic can be over time, right? So 7.6% for China, which means in one decade, they can double their income. And from 1980 to 2018, so they can improve their per capita GDP by over 800%, right? But by comparison, for the United States, 1.7%, in order to reach this level, it's going to take a century or take more than 3 times. Okay, so here to highlight the importance of economic growth. Now we move to next topic. What are the source of long-run growth? Right? So we identify a few things. The most crucial things is labor productivity. Okay, so that's generate long-run economic growth. But what is labor productivity? So essentially, it's output per worker. How much value added, or how many goods and services a typical worker can produce. So that is crucial important to generate long-run economic growth. Okay. So besides this labor productivity, so if we have increase in physical capital, and then so we can increase the output, or in some sense that can increase the labor productivity, because if you equip the worker with more physical capital, and then the worker can become more productive, like physical capital. Just think about in 1970 and in 1980, the invention of personal computer. So that has dramatically increased labor productivity in the United States. Right. So this physical capital. So physical capital is defined as human-made resources such as buildings and machines. Okay. The other thing is human capital. So this is the improvement in labor created by the education and knowledge and embodied in the workforce. Okay, so like say for example, so we come to to study economics, business, accounting. Okay, so those translate into human capital. That's going to boost up your labor productivity. Right? But we need to understand human capital in a broader sense. So this also includes the way we organize our workplace, like institutions. Okay. So now the next important thing for long-run growth is technological progress, which is defined as advance in the technological means of production in goods and service. Like in this background picture shows, this happened toward the end of 19th century. Right? So Americans find out a better way to refine steels and irons. Right? But remember back in 1900, steel and irons, they are considered the bare bone for modern economy. Right? Okay. So given those 3 important things, actually we talked about 4 maybe, okay? And so we are going to look at an aggregate production function. So essentially this is a hypothetical function that shows how productivity, which is what we really cares, right, is going to depend on the quantity of physical capital, human capital, and the technology. Right? So productivity, so essentially, so that's our goal, or that's the way to measure economic growth. And this production function tells us, so where your productivity coming from, or where your growth coming from, right? And this is summarized by here. Left-hand side is GDP per worker, productivity. Right-hand side, it tells you the source of growth or source of change in GDP per worker, physical capital, human capital, and technology. All right. Okay, so let's just stop here for today. And so next Tuesday, we will pick up from here. Thank you.